All right, video number 2 for today. Hopefully this one doesn't take 15 minutes because that's my cutoff time. And I want to be able to do this all in one. So let's get going. I'm going to talk first about formula mass. I'm going to jump around to a few different slides here. But first we're going to talk about formula mass. And this is basically just calculating the mass of a chemical compound, whether it's the molecular mass or the molecular weight, which is the mass of an individual molecule or atom. Okay, those are going to be in units of atomic mass units, since we're talking small and molecules or atoms. And hopefully this is things that you are familiar with from Gen Chem. Okay, so obviously we're going to take the sum of all of the atoms within a single molecule, and that's going to give us the mass of that molecule. So in this example, they're calculating the mass of one molecule of water, H2O. So they've got 2 hydrogen atoms. So we're going to take 2 times the mass of a hydrogen. And we've got 1 oxygen atom. So we're going to take 1 times the mass of oxygen. And we're going to add those together. So we take 2 times 1.01 plus 1 times 16, and we get 18.02 atomic mass units, which tells me the mass of one molecule of H2O. Okay, here would be a nice way of representing that in terms of an equation. You've got your number of atoms times the molecular weight plus the number of atoms times the molecular weight for however many atoms there are. If there's 7 atoms within that compound, you've got this 7 times. Okay? This is a slide just reminding us that when we start in AMUs, that is the mass in molecules. It is numerically, number-wise, numerically, it is equivalent to grams per mole. Okay? The unit just changes. When we scale this up, we're no longer talking about, so this is equal to 1 molecule. This is going to be equal to 1 mole. All right, and we know that there is 6.022 times 10 to the 23rd molecules in 1 mole. So the number stays the same, the unit is what changes. Okay, we're going to skip around. I don't need to keep those. We're going to go to here. So for composition of compounds, we can write a chemical formula. This chemical formula tells us what is in this compound and how much of each element is in this compound. Okay, so it gives us the relative quantities and the constituent elements. All right. From these chemical formulas, we can determine a percentage or percent composition or mass percent. Lots of different terminologies going around, but we need the mass of the compound, okay, and we need the mass of each element within that compound. So let's just say we're trying to find the mass percent of H2O, okay, and we're going to find both hydrogen and oxygen. In order to do this, we need to find the mass of each element. So element X would be each individual element in 1 mole of the compound. If I have 1 mole of water, I have 2 hydrogens. And I take 1.01 grams because I'm talking about moles. Okay, and then I'm going to divide by the total, which was calculated on the slide a couple slides before. We've got 18.02. That's 2 hydrogens plus 1 oxygen equals 18.02 grams. this number gets multiplied by 100, and that is your percentage of hydrogen. And that will go up there. Okay. For oxygen, there's only one oxygen in this compound, so we're going to take 16.00 divided by 18.02 times 100. That's going to equal your percentage of oxygen. I don't have a calculator with me right now, but your number for that one should go in there for your mass percent of oxygen. Just looking at this, I know that the mass percent of oxygen, when you solve this in your calculator, should be very much higher than the mass percent of hydrogen. Okay, if they're close, you didn't do it right. And they should be close to 100%. They might not always equal 100% just because of rounding. Okay, but all of our percentages should add up to mostly, almost 100%. Let's go, no, don't need to keep those. Let's go again, skipping around. Here's just a concept question that I want you guys to look at. From the formula H2O, which would be the correct ratio that we can get from this formula? I want you to pause, look at these answers, try and answer it for yourself, and I'll explain it here in a sec. Okay, so from a chemical formula, this tells us how many moles of each, or how many atoms of each particular element are within this compound. Okay, none of my answer options involve atoms. Okay, one correct ratio for this could be 2 atoms of hydrogen to 1 atom of oxygen. That would be a correct ratio derived from this formula, but that's not an option. Okay, we know that this is not right because we just looked at how many grams of hydrogen are in a mole of water, and if we have 1 gram of water, we definitely don't have 2 grams of hydrogen. That just doesn't make sense. Okay, same thing here. If we have 1 milliliter of H2O, we cannot have 2 milliliters of hydrogen. It does not work that way. Okay, so C is your answer choice for the correct one, because these chemical formulas, while they relate to atoms, they also relate to moles. So this formula also tells me I have 2 moles of hydrogen to 1 mole of oxygen. Okay? And next slide just tells you that that's the right answer. Let's look at some empirical and chemical formula stuff. This is things that you probably talked about in your Gen Chem or Honors Chem, but we're going to go through it here again in Chapter 3. So the empirical formula is a whole number ratio in the simplest form for the atoms that make up this compound. It's not a ratio of masses. It's the simplest, most reduced form of the ratio of the atoms within the compound. Okay? I can determine it from a couple of different things: percent composition, or the masses of the elements. Okay? Let's look at the steps. We'll go through the steps here together, and then we'll work through an example, and hopefully we get done within our 15-minute time limit. So, step 1 is always going to be change your percentages into grams. If we have 100% of a compound, and 50% is this, 25% is this, and 25% is that, we're going to change that to 50 grams, 25 grams, 25 grams. Okay? If this is already given to you in grams, fine, that's perfect. You don't need to change anything. We're going to start with grams. Step 2 is use a track method, and I'll put this in parentheses here. We're going to use a track to convert grams into moles. Okay, we're going to do that with the molar mass from the periodic table of each element. And then this says write a pseudo formula. I'm not into pseudo formulas. I'll just step to step 4. We're going to divide every mole value by the smallest number of moles. Okay, and this will make more sense once we do it. Maybe you remember from your first chemistry classes. We're going to take those mole ratios and we want them to all be whole numbers. Okay, there's a chance that they are already whole numbers and we can just leave them and assign them in our chemical formula. Chances are, though, that they're going to be not quite whole numbers. So if we have the ratio of 0.5, we're going to multiply everything by 2 to get to whole numbers. If we've got 1/3 or 2/3, we're going to multiply by 3. If we've got 1/4 or 3/4, multiply by 4, and so on and so forth. 0.2 would be by 5. Okay. Here's an example. So we're going to start with grams. If you want to pause this and try and work this through on your own based on the steps that we just went over, go for it. Otherwise, we're going to work through it here. So we've got 165 grams. Remember, we're going to put this into a track. This is 165 grams of carbon. Put this into a track. We've got 27.8 grams of hydrogen. And we've got 220.2 grams of oxygen. Okay, I need to change each one of these grams into moles. And so I'm going to do that by taking grams of carbon on the bottom, moles of carbon on the top. Grams of hydrogen on the bottom, moles of hydrogen on the top. Grams of oxygen on the bottom, moles of oxygen on the top. So in 1 mole of each of these substances, how many grams do we have? That's when we go to the periodic table. Okay, the molar mass of carbon is 12.01, hydrogen is 1.01, and oxygen is 16. If you're cool like me, you remember those numbers. You'll get there eventually if you didn't. And then from here, we divide. So we would take 165 divided by 12.01, grams is going to cancel. 27.8 divided by 1.01, grams is going to cancel. 220.2 divided by 16, and your grams is going to cancel. I'm going to go get a calculator. You guys solve those. Okay, so here's our mole values. From here, we need to divide by the smallest one. And so that is this one, 13.74. We're going to divide every one by 13.74. Oops, 74. That one's going to equal 1. So there's my ratio there. This one's going to equal almost 1. And then 27.52 divided by 13.74 is going to equal almost 2. Okay, I'm running out of time. I'm going to finish this video up. We just have like 1 or 2 more slides in a second video. All right.